Hello. By the introduction, I think you have understood that today's topic is maxima minima. Uh, I hope you have understood the previous topic, that is Rolle's theorem and Lagrange's mean value theorem. Today I have again thought about taking a topic of class 12, that is application of derivative, and in that a very important topic, maxima minima. Before we begin, again the reminder that please do share and like my video as well as my channel. Please subscribe if you have not yet subscribed, and share with your friends so that many more can get the benefit of the video. Anyway, without wasting much of our time, let us begin with the topic maxima minima. From the term or the word maxima and minima, you can guess that it is something related to something highest and lowest. Now it is related to functions. Let fx be a real valued function, real valued function defined in the domain D, which is a subset of R. Then if we get a point C in the domain D, C belongs to the domain D, such that f of C is greater than equal to f of x for all x belongs to D, then this f of C is known as the maximum value. Very easy to understand. That means whatever point we take other than the number C, we will get it more than f of C, and this point C is known as the maximum point. This is also known as the absolute point or absolute maximum. Absolute maximum because in the whole region of definition of the function fx, f of c is the highest value or the maximum value. If you have understood the maximum value, then the minimum value also goes the same way. That is, if we get a point, say D, belonging to the domain of the definition of the function, and if f of c is less than equal to fx for all x belongs to the domain D, then it is known as the absolute minimum, or D is known as the minimum point. So this was the definition of absolute maximum and absolute minimum. Now we shall go and understand what is local maximum and local minimum. Well, now let us understand the concept of local maxima and local minima. We have understood what is absolute maximum and absolute minimum. Now let us observe this graph. If I have drawn a graph of a function y is equal to say fx, y is equal to fx, now we can see that at these positions the graph has attained peaks, and here it has attained depressions. Here also it is a lower peak, and here it is again the upper peak. So what we understand here is, in this locality, this point is the highest or the maximum. In this locality, this point is the highest. Similarly, in this locality, this is the highest, although it is negative side. So Local maxima or local minima means there exists a point C so that f of C is greater than equal to f of x in the neighborhood of C minus delta and C plus delta. What is this delta? Delta is a small interval beside C. If C is a point here, then this is C plus delta and this is C minus delta. In this interval, this is the highest, that is the peak. That is known as the local maxima. It is just like localized, means at that point fx is highest. Similarly, here if I notice at this point, this is the least value. So this is known as the local minima. So here f of C is less than equal to f of x in the same interval. So a local maxima or a local minima may not be an absolute maxima or an absolute minima. Local maxima or local minima is only for a localized point or a local area. But absolute maxima or absolute minima is the maximum point throughout the domain of the function. That is the main difference. I hope you have understood the difference between local maxima and absolute maxima. Same way local minima and absolute minima. Now on the same run, let us understand what is the meaning of turning point or critical point. Now if I observe this graph, we can see that at this point the values of the function start changing. Even at this point it was decreasing, all of a sudden it starts increasing. Then again it starts decreasing. Then again it's increasing. So at this point, at the peak, we will find it is neither increasing nor decreasing. Even here, 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 here. So at this point, if I draw a tangent, the tangent is always parallel to the axis which is drawn horizontally, that is the x-axis. And if the tangent is drawn and it is parallel to the x-axis, the slope of the tangent at these points, they will be 0. Derivative at these points, they will be 0. So from that point, it starts changing. So the points at which the derivative becomes 0 are the points of change from increasing to decreasing or decreasing to increasing. And those points, these points are known as the turning points or points of stationary or stationary points, or sometimes it's also known as critical points. So turning points are the points where dy by dx is 0. So from this we understand one thing. In order to calculate which points the function attains its maximum or minimum, we should know at which point the derivative of the function vanishes or where the derivative becomes 0. So in order to calculate the maximum and the minimum point of a function, first of all we should find out the derivative of the function. If fx is given, we should find f dash x and we should equate it to 0. Correspondingly, we get the values of x. Whatever the values of x we get, now at this point the function's derivative is 0. Whatever values we get, we should substitute in fx and we should see for which value it attains the greatest value, that is the absolute maxima, and for which value it attains the lowest value, that is the absolute minima. This is the working rule for finding out the absolute maxima or the absolute minima for a given function in its given domain. So I think you have understood the concept, its working rule. Let us move on to the examples to understand how to calculate the absolute maxima and the absolute minima of a given function. Well, to understand the concept of absolute maxima and absolute minima, let us take this example. Fx equal to 2x cube minus 9x square plus 12x minus 5 in the interval 0, 3. This is the domain of the function. Now, the working rule for calculating the absolute maxima and absolute minima is, first of all, we will find out the derivative, first order derivative, equate it to 0 to get the turning points. Then find the value of fx at these two endpoints as well as the turning points, and then compare whichever is the highest, that will become the absolute maxima, and whichever is the lowest is the absolute minimum. Okay, let us find out f dash x, that is 8x square minus 18x plus 12. Is it okay? Sorry, it is not 8, it is 6. 6x square minus 18x plus 12. Now at maxima, minima, f dash x is 0. Therefore 6x square minus 18x plus 12 equal to 0, or x square minus 6 is 80 plus 6 to the 12 equal to 0, or x minus 2 x minus 1 equal to 0, or x is equal to 1 comma 2. Is it okay? So we have got x is equal to 1, x is equal to 2. Now let us find the four values, f of 0, f of 1, f of 2, f of 3. f of 0 is 0 minus 0 plus 0 minus 5, that is minus 5. f of 1, that is 2 minus 9 plus 12 minus 5, that is 12 and 2 14 minus 14, that is 0. f of 2, that is 8 to the 16, 4 9s are 36 plus 24 minus 5, 16, 24, 30, 40 minus 41, that is equal to minus 1, and f of 3, that is equal to 27 to the 54, 81 plus 36 minus 5, that is 60, 90 minus 86, that is 4. So we have got the values minus 5, 0, minus 1 and 4. You can easily compare. 4 is the highest value and minus 5 is the least value. So absolute maxima is 4 and absolute minima is minus 5. So the function attains absolute maxima at x is equal to 3, and this is the absolute maximum point, and attains the absolute minimum at x is equal to 0. So this was how we calculate the absolute maxima and absolute minima. Let us see the next example. Our next example is fx is equal to sin x plus cos x in the domain of interval 0 to pi. So let us find out f dash x, that is cos x minus sin x at critical points or turning points. F dash x is 0, so cos x minus sin x is 0, or cos x equal to sin x, or we can say tan x equal to 1. Is it okay? Implies x is equal to pi by 4. So we are getting only one critical point. So let us find the values at these 3 points, 0, pi and pi by 4. F of 0 is what? Sin 0 plus cos 0. That is 0 plus 1. That is 1. And f of pi by 4, that is sin pi by 4 plus cos pi by 4, that is 1 by root 2 plus 1 by root 2, that is 2 by root 2 or root 2. And f of pi is sin pi plus cos pi, that is 0, sin pi is 0 and cos pi is minus 1, that is minus 1. So we get 3 values, 1, root 2 and minus 1. Obviously root 2 is the greatest and minus 1 is the smallest or the minimum. Therefore absolute maxima is equal to root 2 at x is equal to pi by 4. So x is equal to pi by 4 is the maximum point, absolute maximum point, and absolute minima is equal to minus 1 at x is equal to pi. I think by these two examples we have understood how to calculate an absolute maxima and absolute minima. Now we will see how to calculate local maxima and local minima by using first order derivative and checking with the help of second order derivative. Well, in this function we are supposed to find out the turning points and distinguish between the local maxima and the local minima. Now in order to calculate the local maxima and local minima, the working rule is we will first of all find out the derivative and then equate it to 0 and get the points at which it is turning, and then find out the second order derivative in order to check whether it is maxima or minima. So what is the process? First f dash x will find, equate it to 0, get the points, and then find out d2y by dx square or f double dash x and put these points here. If the points are positive, then it is minimum, and if the points are negative, then it is maximum. This is the rule. So let us find out f dash x here. This is 3x square minus 6x plus 3. At maximum or minimum, f dash x is 0 or 3x square minus 6x plus 3 equal to 0, or x square minus 2x plus 1 equal to 0, or x minus 1 equal to 0, or x equal to 1. I hope you have understood. Now this x is equal to 1 is either maximum or minimum. So how do I do? For this I have to calculate f double dash x. F double dash x is 6x minus 6. Now putting 1 here, we will get 6 into 1 minus 6 equal to 0. Now 0 is neither positive nor negative. Now, how do I understand then what it is? So, it is neither maximum nor minimum. This type of points are known as points of inflection, where it is neither maximum nor minimum. Let us see another example. So this function does not have any local maxima or local minima. The function has no such point because we are not getting either positive or negative. We shall see an example where we get maximum or minimum. See this example, fx is equal to x cube minus 3x. So as usual, we find out the first order derivative, that is 3x square minus 3. Our next step is we equate it to 0. Then 3 is common, x square minus 1 equal to 0, x minus 1, x plus 1, 0, x is 1 comma minus 1. So 2 points we have got. In order to check whether we have maximum or minimum point, we find out second order derivative, that is 6x minus 6x, this is 0. Now at x is equal to 1, f double dash 1 is 6 into 1, that is 6, this is greater than 0, implies fx is minimum at x equal to 1, and minimum value is, for finding minimum value we'll put it here, f of 1, that is 1 minus 3, that is minus 2, and at x is equal to minus 1, f of f double dash minus 1 is, we'll put here 6 into minus 1, that is minus 6, which is less than 0. fx is maximum. Therefore, maximum value is f of minus 1, that is minus 1 cube minus plus 3, that is minus 1 plus 3, that is 2. So maximum value is 2 and minimum value is minus 2. So this is how we calculate the local maxima, local minima, local minimum point, local maximum point. I hope the session was quite interesting. You could follow each and everything which I told. If not, you have a way to ask me in the comment box, and please be with me so that I can share more and more knowledge with you which can be beneficial for you for your coming exam. Take care. Bye bye.